All right, question six. I mean, we're applied calc two. You're probably looking at this, and you know that if I take this limit as n approaches infinity of 1 plus 1 over n to the n, you probably know that this is equal to e to the first power. So this thing's going to converge. Now, if you're like, how do you know that that thing is equal to e? Well, let's see, right? So if all you do is care about whether converges, so you recognize it, good, you're done. But if you actually care, let's see. So suppose I say that so I have some a to the n equals 1 plus 1 over n to the nth power, right? So I kind of have an issue here with this exponent. So how do we fix exponential problems? We take natural logs. Right? So if I took the natural log of a sub n, I would take the natural log of this side as well. So we're going to get the natural log of a sub n, my nth term, is equal to n times the natural log of 1 plus 1 over n. So if I took the limit of this side as n approached infinity, it would equal the limit of this right side approaching infinity. But there's a little bit of a problem here, right? Because I know that this n here would go off towards infinity, 1 plus 1 over n. This thing is approaching 1 plus 0. So we have the natural log of 1. So this thing is approaching 0. So I have like infinity-ish times 0-ish, right? So what's going to dominate? So we can pull out a little trick here, right? We can say, I can take this limit as n approaches infinity, and I can say I'm going to multiply it by 1 over n over 1 over n, right? So I'm just, in this case, multiplying by 1, n times 1, sorry, the natural log of 1 plus 1 over n. And so by doing that, what ends up happening? These cancel out, and I'm left with this limit of 1 over 1 plus n over 1 plus n. All right, so why does that help us? Well, now when I try to take this limit as n approaches infinity, this is going to approach 0. 1 over n is also going to approach 0. Look at that. We have 0 over 0. We have an indeterminate form. You know how to handle indeterminate forms? Our old boy L'Hopital. So at this point, we can use L'Hopital's rule. So by fancy L, L'Hopital, we know that the limit that we're trying to take is going to equal the limit of the derivatives, right? So if I take the derivative of 1 plus, or the natural log of 1 plus 1 over n, right? That's a little bit of a chain rule. So we're going to get 1 over 1 plus 1 over n times the derivative of the inside. The derivative of 1 plus 1 over n, well, the derivative of 1 is 0. Derivative of 1 over n is going to equal negative 1 over n squared. The derivative of 1 over n in the denominator here is going to be negative 1 over n squared. Notice that these two terms now cancel out. So we're left with the limits of 1 over 1 plus 1 over n. Well, as n goes off towards infinity, this is going to be 1 over 1 plus something that's approaching 0. So this is going to approach 1. Now, if we think about where we started, right? So we said that where we're at. So the limit, so a sub n was equal to 1 plus 1 over n to the n. So we also saw that the natural log of a to the n is now equal to 1, right? So we showed that this equals 1. So that means that if we took, or the limit of this equals 1, so thus a sub n, if we're trying to undo this natural log of a sub n equaling 1, a sub n is going to equal e to the first power. Right, so that's why 1 plus 1 over n to the n equals e.